Use the apportionment method's applet to answer the question below. A small nation consists of 4 provinces with individual populations listed in the following table. There are 49 seats to be apportioned. Determine the apportionment using each of the 4 methods illustrated in the applet. We're given the following table where we have 4 states A, B, C, D, and the following respective populations: 1,000, 2,000, 2,500, and 4,000. You'll then click the blue link, click here to use the applet, but let's look at the statements here. Which statement best describes the best comparison between the results of the 4 apportionment methods? A, apportionment works under Jefferson's method but not under Adams' method. B, apportionment works under Adams' method but not under Webster's method. C, apportionment works under Hamilton's method but not under Jefferson's method. And D, apportionment works under Hamilton's method but not under Webster's method. So in order to do this, we need to go ahead and use the applet that is given to us. So if we go back into MyMathLab and we left click the link for click here to use the applet will open. Now, one of the things about the applet is you need to make sure that Java is enabled on your computer and that the security settings are set so that it will run this applet. The first thing that you need to do is go to this tab, Create Table, and left click it, and that will bring up the table that we want to create. Now, you'll see that the table only has 2 states, A and B, so we need to come down here and we need to increase the number of states to 4, and you'll see that it's added 2 more rows. Here in the green, we are going to go ahead and left click for this first one, and for state A we will type in the number 1000. Don't worry about the 0 in front, because as soon as I left click somewhere else, it will write it in the proper format. This will be 2000. We'll left click in the next one and type in 2,500. Notice that I am not using commas, and this will be 4,000, and I will left click somewhere else. Down here where it says number of seats, we need to make sure that this number is correct, and the number of seats is 49, so we will just go ahead and highlight this, type in the number 49, left click, and we're going to left click compute. Now, alright, now we have this. Alright, so now that we know what the table looks like, we're going to go back in and we're going to look at Hamilton's method, Jefferson's method, Adams, Webster's, and the Huntington-Hill method. And then we'll talk about the method comparison. So when we look at this table, if we go to Hamilton's method, we need to allocate the surplus seats, which means that we will do the first surplus seat, and you'll notice this goes right here, and then we will allocate the second surplus seat, and now we have this table totaling to 49 for the apportionment. We're going to look at Jefferson's, and we'll see that the standard quota is 49 and the modified lower quota is 47. Then we'll look at Adams, and we'll see that the standard quota is 49, but we have an upper quota violation here of 51. So that means that Adams' method does not work for this apportionment. We'll look at Webster's, and we'll see that the standard quota is 49 and the modified rounded quota is 49, so this works. And the Huntington-Hill method also has a standard quota of 49 and an apportionment of 49. And then we'll left click the method comparison. And this right here is what's going to tell us which one works and which one doesn't work. So let's go ahead and look at it so that we can add up the columns, because that's what's going to help us. And if we go ahead and total these columns right here, which is going to give us the information we need to help us determine which one works and which one doesn't, this right here sums to 49. This column sums to 47. This column under the Adams method will sum to 51, and both the Webster's and the Huntington-Hill method will sum to 49. So now remember that up here you'll see where it says number of seats is 49. That is the key to the problem. So Hamilton's method for apportionment would work. Jefferson's method would work since it's less than 49. We'll see right here that Adams' method will not work. We'll see that Webster's method works, and we'll see that the Huntington-Hill method will work for the apportionment. So Adams' method does not work. The others do. So we'll need to go back and we'll look at our wording of the problems. So remember, this is a multiple choice problem. So we're going to look to see which one of these works right. All right, this says apportionment works under Jefferson's method but not under Adams' method. Well, that happens to be the correct answer, because Jefferson's method does work since the apportionment is 49 or less, and Adams' method does not work since the apportionment is 59, and that's larger than the number of seats in the problem. So we would go ahead and we would select A. But let's go ahead and look at the other three statements. This says apportionment works under Adams' method, but it doesn't. So I can discount this one completely and totally. So I'm just going to put an X right there. This one says apportionment works under Hamilton's method, which is a true statement. This works. Hamilton's method does work. But not under Jefferson's method. But we've just shown that Jefferson's method does work. So this is a false statement, so we'll discount it. And then the last one, D, apportionment works under Hamilton's method. We know it does, but not under Webster's method. But once again, we know that Webster's method does work because of the apportionment of 49. So I can discount this, and we see that our choice is logical. Apportionment works under Jefferson's method, but not under Adams' method. And so we would go ahead and we would left-click that radio button and check our answer, and we're done with the problem.